Hey guys, welcome to day 7 of Coding Every Day until Codeforces GM. There's a contest tomorrow, so I guess today we're just going to do some general contest prep, just doing some 1200 rated problems until I get comfortable. 'Cause I would say 1200 is the types of problems that like I can barely solve it. It's like I'll struggle for a good amount of time, and then I'll be able to solve it um, with minimal assistance. So I say we just work on 200 or 1,200 problems today until I feel comfortable. Hopefully this video doesn't drag on too long because some of these do take a little while. But yeah, as y'all can see, I have already started this problem, worms. And basically what it's saying is there are, so you got Mole here, he's blind, and his friend bought him a ton of worms, and they're in different piles. So this one's saying the first pile has 2 worms, second pile has 7 worms, third pile has 3 worms, etc., etc. And then since Mole is blind, Marmot will tell Mole the location of these worms. So, or the location of the juiciest worm. And Mole can't eat all of them, but he wants to eat the juiciest ones. So, Marmot tells him the first juicy worm is 1, is labeled 1. So, that would be in pile 1. So, that's what we'd output. We'd output the pile it's in. Since the next juicy worm is in pile 25, we would basically add these up and find 25 and then tell them what pile's in. And it happens to be this one down here. So it's 5. And same with 11. This is 9, 12. So it's in pile 3. Makes sense? Now, I started with an implementation, tried to brute forces as I usually do. I just take in some input, sum the array together, so I have it like, where's my Scala draw? Here it is. But okay, so this is my thing from index 0 to sum a. This is the array I'm talking about here. I was playing around with the binary search approach here, which is probably what I'm going to end up doing. But yeah, you can see that this is a sum array. So starts at 0, and then 2, and then 9 is 2 plus 7, and then 12 is 9 plus 3, and etc., etc., etc. So that's basically how that's going to work. And then over here, we're iterating through the M array, or the Q array, and for each I, or so for each element in N, we'd check if it's less than the value in the sum array. So it'd be, if it's 1, we'd check if it's less than this value. If it is, print it out. And if it's 25, we check. It's here, then we print it out. The problem with this is it's too slow, runs into this TLE here. So let's comment this out. and let's work on a binary search approach. So here's my problem with these 1200 rated questions is like I I can recognize the data structure. Well, it helps a lot that the tag is right here, but I know what the data structure is. I just really struggle in implementing it in different contexts. So, like I guess that's what we'll be working on today. It's how can I change this brute force approach into a binary search? So let's think. I think we need to keep this line because we're iterating through the. We have to iterate through the Q array. In fact, I don't think we need this at all. We're just for blank and Q. And then, I mean, standard binary search implementation is take a left and a right pointer and then set it to like the two ends, right? So this is 0. Yeah, this is left. This is right. And then while left is less than right, calculate a midpoint, which is just left plus right divided by 2. And then if left is less than right, do something else. Elif left right else. So, and we need to increment, or we need to change our R value to midpoint. So if left is, if L is less than, wait, no, it's, this ain't right. It's like, how does it work again? It's like, if, okay, so I know you have to, it's like, we have to, no, this is wrong. If we need some sort of target, right? To print equals okay, so in order to check, it's basically it's going to be under this value. So we check the highest. Yeah, if q is less than or equal to sum. So to print needs to be in -1. Right. Which is just R by default. Set to print to R. And then if the target okay, standard binary search is like you get like some array. You set the array to mid, the array index to mid, and It's like if double equals, if and double equals, like you have some array m equals target return m elif rm is less than target, L equals m plus 1, just else r equals m minus 1. This is like the standard binary search checking, alright? Now, how do we implement this for our case? We have to print, and we have a sum A. If so, sum A is going to be our array here, right? Sum A mid m sum A m is equal to underscore. Why did I call this underscore? I could have called this anything in the world. For pile and q. If sum A is equal to pile, return m. So to print equals m. Well, realistically, if it's less than or equal, if sum A is less than or equal to right. Okay, wait. Let's just build this out. Else elif else. So elif sum am is less than pile. Like, this isn't exactly right because we're not looking for a number, we're looking for anything less than a number. Like, does this work still though? If it's equal to, no, because it's not a direct number. It's not like 1, 2, 3, 4, 5. It's not continuous. If sum A is uh, hmm. How do we actually handle this? It's like sum A plus pile. No, sum A. This is pile. No, pile will be over here. This is sum A m. If sum A m is greater than pile, if sum am is less than pile, what do? We need to change sum am. Wait, sum am is less than pile. We need to change our pile. We need to change for pile and Q. Wait, is it supposed to be pile? It's not pile, it's tag. For tag, that's why it was so confusing. For tag and Q. So if our tag, if sum am is less than tag, we need to change sum am. If sum am is greater than tag, then it's likely our answer to print equals m. Right, if sum am is greater than tag, then we need to move our right pointer to m. R equals m minus 1. Else, we need to move our left pointer to m plus 1. Right? If our sum, if sum A is, okay, let's just, if sum, let's just check with case 1. If sum A, okay, how would this work? Checking with 1. The left is 0, right is 25, and our mid is 12. If sum A is greater than sum, so we're doing sum A 12. Sum A 12? Oh no, it's not direct calculation, it's indexes. So 0, 1, 2, 3, 4. 4 divided by 2 is 2, so sum A 2 is 12. Is 12 is greater than or equal to 1. So set to print to 1 or to 2, and we move R to 12 to 2 minus 1, which is 1. And then 1 divided by 2 is 0. So we're here. This is M. Sum A 0 is 2. But it's still greater than tag. So to print is set to 0. And then R is set to 0. I guess it could be, just do this. Is this it? I think this is it. 5. The 25. We just go here. Sum A4 is, so you do this, trigger, and then we would have to move right to n plus 1, which is 3 over here. Is equal to, we check one more time. It's less than now, so we'd move like here, right? And then it would end. I think this is it. After the while loop, print to print plus 1. 1, 5, 3. Okay. Mm, 22 minutes. Not too bad. Although I have been on this problem for like an hour off cam. There we go. Another problem I'll have to bookmark because that was not smooth. That was not smooth at all. Like if I can get these 1200 problems down to like maybe 30 minutes, I would be pretty happy. No, I don't like the look of this. This has like 50 million different tags, but we can try it out, I guess. Versu ball. 4, 8, 9, B. Versu ball. This uni is hosting a ballroom dance. Several BG pairs are divided, however the partners must differ by their skill must differ by at least 1. For each boy we know his dancing skills. Similarly, for each girl we know her dancing skills. Write a code that determines the largest possible pairs that can be formed n boys, m girls. First line, number of boys. Second line, sequence. Third line, number of girls. Fourth line, sequence would be okay. Maximum number of possible pairs. So what First line is the number of boys. Second line is a sequence where AI is the ith boy's dancing skill. So okay, it's just an array of dancing skills. Int or input b equals or n. Sorry. Okay. N equals int input. Let's just copy what I have going on here. It's the same type of input. NM and then AB. Pairs must differ by at most one. Must differ. So they can't be the same. Three pairs. So how would they pair up? This girl with these two boys as one pair, two pairs. This one, three pairs, four pairs, five pairs. Huh? Largest plus one pair. This is two. Five boys. The largest possible number of pairs that can be formed. Oh, so it's not like it's two because any combination of boys you'll still get two. These guys can't pair up ever, and these guys can pair with all of them, so the max is two. Okay, that makes sense. It's not like counting how many different combinations you can make. Now, how do we do this? Greedy sorting's two-pointer. Well, I know sorting. I can just sort it. A dot sort, B dot sort. Go. We sorted two arrays. Yippee! Now, DFS and similar, DP, graph matching. What does that even mean? Oh, DP, we did DP yesterday. What was the question that we did yesterday? Boredom. Okay. We defined a DP function. Length. What's the length of this? The length is the minimum of n and m plus 1, right? because you can never have more pairs than the length of the arrays. dp0. So how did boredom go? Boredom was like you could select the current one, or you could select the next one. Right. Do we need a count array? Wait, hold on. Must differ by at most one. At most one. So it can't differ by two. So one and less must differ. So are they saying these match up? Because I understood it as these match up when I first read it. But I don't like how they use must. They must differ. Then these don't, one and one don't differ. But it has to be because it's at most one. So I'm thinking we start with the... It's greedy. So we start with the largest skill in all the arrays and try to match them. If we can match them, plus one pair. If we can't, move on to the next. Etc, 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 etc. So we sorted. What if we sort reversed? Okay, well I do think we need to count an array. Count A, count B. Now what? So what do we know? 1 must differ by at least 1. So AI minus BI is less than or equal to 1, right? So okay, so we basically want to match the skills. Like here's my like thinking. Let's move to some empty space. Um, where did it go? Here. So these are our two arrays. We want to sort them so that we get 1, 2, 4, 6, 1, 7, 1, 5, 5, 7, 9. And then we basically want to match skill levels. Like, we want to try our best to match lowest with lowest and highest with highest, like, whatever. You get the point. But that's the thinking, right? So like, this is a greedy pairing. So we take an input, sort. Maybe we don't need these counters. We do need one counter. We can call it pairs. And basically, this pair, we increment pairs if the absolute value of boys I minus girls j is so AI minus bj is less than or equal to 1. Pairs plus plus. Right. So now we need a track. I and J 2-pointer. Okay. Right. There's worms over here. Alright, we can define it all in one line like this. And then, okay, so for in range max nm, if abs pair plus 1, I plus equals 1, j plus equals 1, elif. If the boy's too small, AI is less than bj, increment I, else the girl's too small. So, right? So then we would just print pairs. Yeah. It broke. Jover. Index out of range. Uh, Here, if boys I index out of range because there's no more to add. Because max. Because if the boy is always smaller, then you would increment, the max is 5 and we'd run out of room. So this isn't it. Is it min? Min and m. But then you wouldn't check one of the girls. This is wrong. How can we... So we keep going until we're either out of boys or girls. So I is less than n or j is less than m. Or and. So both of them needs to be less than their corresponding. Can I use a while loop? While I is less than n and j is less than m. Hello? Where's my less than sign? Does this fix it? Copy. Paste. 3. Zero. 2. Okay. This seems like it. This is low-key not that bad. I guess the hardest part was like starting the question. It threw me so many tags, I was like all over the place. Just 2 pointers. You track 1 pointer for each array and then count pairs if the conditions match. If not, increment the pointers. I wonder what the DP solution would look like. There we go. Or like the graph and matching, DFS and similar. Well, let's take a look at it. There's about 10 ways to solve the problem. You can find maximal matching in a bipartile graph, write DP or just use greedy, Let's sort by skill. Lowest skill can be matched. It's a good idea to match them. I can't reduce answer size. Use girls with lowest skills to match. Right, sort. These are the 2 pointers, right? Okay, that's pretty much what we did. We just tracked 2 pointers because we used a while loop. And then this was important. Like, was this even the crux of the problem? Like, this seemed so much easier than the one we did yesterday. But, okay, how long is my recording? If it's over an hour, we'll call it 46 minutes. Should we do one more? One more easier problem? These are hurting my head. I'll definitely review this problem too. Let's do something easy. 1000. Who messaged me? It doesn't matter. Chat room. I'm familiar with chat rooms. I have some code on my GitHub for one. 58A. Chat GPT .py. Okay. Rating 1000. This person has learned to type and log on to the internet. Entered the chat room, said hello, typed word S. Considered if so, this would be considered saying hello. Got misunderstood because it doesn't have a U. Or it doesn't. Wait, what? It doesn't have a HE. Wait, what? Several letters can be deleted from the typed word. Okay, so yeah, U can be deleted. No letters can be deleted. This can be rearranged to be hello, but no letters can be deleted. Okay, that makes sense. Given a string, determine whether we can say hello. So I'm thinking about like a counter right now, and we count all the letters, and then if it matches up, several. So does one count? If it's equal to hello dot if it's equal to len hello plus two, one's not considered several, one, right? One's considered one. So counter from collections import counter. I've never actually used counter before, have I? From collections import counter. Counter. Looks like I can just call it letters equals, let's take an input. I can do in count letters equals encounter int input, or it wouldn't be int, it's a string. And we'll print letters. Okay. It looks like I can just use it like a normal array. Then if hello equals counter hello, if hello in letters and yes. Now, does this work? No. Unhashable type counter. Um, hmm. Like I'm thinking like some sort of like sub-dictionary behavior right now. If hello is like a sub-dictionary of letters, how would I do that? Like key values if what does this do? Dot items print hello dot items. Ticked items. Ooh, a list of tuples. Wait, that's good. Can I compare these? Something like if letters dot item if hello dot items in letters dot items print hello. Is less than or equal to. No. Oh. work? Nothing was printed. That's something we'll do. No? No, this doesn't work like this. Helou. There's gotta be a way to compare these, right? Uh, yeah. That's what this other thing said too. That's what I was looking at on my other tab. So Stack Overflow. Yeah, this one. So why isn't it working in my case? Nothing is printed. Else. Print dum dum. Dum dum, it's printed. Huh. This just doesn't work, bruh. Or is it cause like these actually have count like oh that might be the case. Hmm. Check if dick is check if counter is subject of another counter. Okay. What they do? It's just this? Hello. Oh! Well, that worked. Is that easy? Wait, what? Uncomment save. Where's the question? There we go. That makes it a lot easier. Now, how do we sum? Sum my dict. If sum. Okay. If this and sum hello is plus 2. Okay. So sum hello plus 2 is less than or equal to letters. If letters minus 2, the same thing, but it makes more sense, right? If we can remove 2 from letters and it's still greater than or equal to hello, then we print yes, else print no. That didn't work. Hello dot keys. Jover. For plus int and string? Values. Jesus. Right? Yes. No. Okay, well, if anything, this problem taught me how to use counter. It's wrong. I'm gonna kill myself. Jerry's answer is no. Hello. Hello. How does this not match up? If several letters can be deleted. So that, for example, I mean if several letters can be deleted. We can delete. Yeah, we can delete a lot of letters. Uh, this works. Why? Why no? We can delete KWY. Why is this no? I don't get it. This is you can HELLO. Oh, does it have to be in order? Like it can't be scrambled? That might be it. That might be it. The implementation might be a little different then. Okay, so is this just straight up wrong? Like, okay, we have to take an input. Hello. Hmm. For character and letters, if okay, let's just track a separate array. this, like we can have hello equal to hello, and then we can have a hello pointer equals 0. If char equals hello I plus plus, and then if I is equal to len hello break. If I is equal to len hello print yes, else print no. So we go through, check the chars. If chars hello I plus plus, if I ever equals to the length of hello, we stop. If we go through all the chars and we don't increment enough, then we just end. Okay. No. Okay. There we go. Alright. If y'all enjoyed this episode, be sure to like and subscribe. And I guess I'll see y'all tomorrow.